All right, so I've titled this View Adaptation as an Opportunity for Economic and Community Revitalization. Let's do some climate reality review. Starting from the 1880s, we have a very well-founded idea of how greenhouse gases have accumulated. Here you can see carbon dioxide, and this is the parallel rise in global temperature. You can see it's highly variable with hot years and cooler years, but the long-term trend in temperature is very clear. Overall, CO2 accumulation is accelerating. Warming is also accelerating. We've currently warmed the planet about a little over 2 degrees Fahrenheit or 1.2 degrees Celsius. And we're on track to achieve about 1.5 degrees Celsius of warming above the natural background by the end of this decade. And another 15 years after that to hit the target of 2 degrees Celsius. Both of these are United Nations targets that have been agreed to by the world as temperatures where we need to stop the warming. As you'll see in the next couple of slides, this is going to be very difficult. It is now no longer simply about cutting greenhouse gas emissions. The pace of climate change has been rapid, and over the past century, few people other than scientists have noticed. In the first 80 years of the 20th century, a new global temperature record was set roughly every 13.5 years. But in the past 40 years, we're setting temperatures now approximately every 3 years on average. Annual greenhouse gas emissions continue to set new records, and the rate of carbon dioxide growth in the atmosphere has more than doubled. The International Energy Agency has projected that energy demand by 2040 is set to grow more than 25%. And they say in their report, which was published last year, by 2040, renewables will make up only 2/3 of new capacity, and oil consumption grows due to rising demand for petrochemicals, trucking, aviation, and energy every year. Another institute, the congressionally funded Resources for the Future Institute, projected that global energy consumption will grow between 20 and 30% or more through the year 2040 and beyond, led largely by fossil fuels. They stated that renewable energy grows rapidly, though it primarily adds to rather than displaces fossil fuels. The truth is that fossil fuel use is actually accelerating faster than renewable energy use. And you can see here, updated to last year, the increase in use of fossil fuels has outpaced the increase in the use of non-carbon forms of energy. So among these climate change realities, we can ask, will carbon removal technologies counteract rising greenhouse gas emissions? In 2018, 23 commercial scale carbon capture and storage projects were in operation or under construction around the world, capturing 40 million metric tons of carbon dioxide annually. Unfortunately, this is 1/1000th of what our annual emissions are. We also have what's known as committed warming. That is, greenhouse gas emissions originating today will not contribute to global warming for another 10 to 30 years. We have the phenomenon of global dimming. The rise of clean energy will allow more sunlight to enter Earth's atmosphere because we are replacing the pollutants that are generated by fossil fuels, and this enhances warming. So this committed warming averages is thought to average roughly 0.5 degree Celsius of additional heating that would occur even if we were to stop all emissions now. And so we've probably already committed to breaching the first Paris target of 1.5 degrees C. We also have the reality of the carbon budget. For a 2/3 chance of keeping warming below 1.5 degrees C, we can only emit another 420 billion tons of carbon dioxide. We are now averaging something above 40 billion tons of carbon dioxide emitted every year. And at 1990 levels, we have less than 10 years of emissions before we're committed to a 2/3 probability of warming 1.5 degrees C. There is the decrease in emissions due to the COVID pandemic, and I'll be happy to take a question on that, but I won't cover it right now. The fact is that emissions have to quickly fall to around 20 to 30 billion tons of CO2 per year this decade, and then sharply continue to drop towards zero, reaching zero emissions by mid-century in order to stay within the budget. Unfortunately, most of the world's energy economists are projecting a rise in global carbon dioxide emissions, averaging on the order of 50 billion tons per year just by the end of this decade. Thus, staying within the carbon budget for 1.5 degrees C will be extremely difficult. We also have existing infrastructure. If existing sources of fossil fuel emissions, such as factories, cars, and power plants, simply continue to operate for their expected lifetime, that is another 650 billion tons of carbon dioxide, which is 55% more than allowable emissions for this 2/3 possibility of stopping warming at 1.5 degrees. Decommissioning such infrastructure, considering how expensive it is before its planned lifetime, puts at risk enormous levels of invested capital. It puts at risk jobs and entire communities that have been built around these assets. Of course, global warming leads to sea level rise, and today's sea level rise reflects not only the influence of present-day warming, but past warming as well. There is a time lag of decades to thousands of years between air temperature and the adjustment of glaciers and oceans to reach an equilibrium to that air temperature. It's analogous to taking a great big block of ice and putting it on a table in your room. It doesn't melt like that. It takes time. And that's the same sort of inertia that is involved in warming the ocean, which leads to thermal expansion and melting the ice sheets of the world. So today's rate of sea level rise acceleration doesn't actually reflect today's level of global warming. So today's acceleration is going to increase. The current rate of acceleration is on pace to over 2 feet by the end of the century. And there are certain geophysical effects on the planet related to melting the ice that mean that Hawaii and other tropical Pacific locations will see someplace between 20 and 30% more than the global rate of sea level rise. So between temporal lags, committed warming, carbon budgets, and continued emissions, it's extremely likely that global warming and hence sea level rise will continue to grow. Sea level rise will likely increase and by the end of the century may exceed 3.2 feet. Studies, in fact, identify a 10% probability of sea level rise reaching over 6 feet. And beyond this century, sea level will continue to rise for centuries due to continuing deep ocean heat uptake and mass loss of the Greenland and Antarctic ice sheets. This will remain, the sea level will remain elevated for thousands of years. We know that portions of the West Antarctic ice sheet are already in a state of irreversible collapse. And between 2 and 3 degrees of global warming, Antarctic ice could raise sea level 10 feet by the year 2300 and continue for thousands of years thereafter. We are worried about ice streams in the East Antarctic ice sheet and the fact that they are demonstrating elements of instability. And the Greenland ice sheet may pass a tipping point once we pass 1.5 degrees C of net warming. Ice is being lost from Greenland 7 times faster now than it was in the 1990s. Over 90% of the heat trapped by greenhouse gases is absorbed in the ocean, and this leads to thermal expansion, which over the past decade and a half is responsible for about 1/3 of global sea level rise. Today, we measure global sea level rise using satellite altimetry, a mission that began in 1993, and since then, we have seen a long-term rise over that period of about 1 foot per century. But if we look at just the last decade from satellite altimetry, we see that the rate of global sea level has accelerated to 1.5 feet per century. So what does this look like locally? Here is an aerial photo of Waikiki and Kaka'ako at today's mean higher high water, which is the average of the highest tides of the day. With 1 foot of sea level rise, we begin to see the edges of the Alawai and other coastal areas experiencing some flooding. At 2 feet of sea level rise, the Alawai golf course turns into a wetland. And between 2 and 3 feet of sea level rise, we see a dramatic change from what would be more minor flooding to very dramatic and persistent flooding. At 4 feet of sea level rise, 5, and 6 feet of sea level rise, we look at an expansion of the flood zone and a deepening of the flood zone. And again, 6 feet of sea level rise, in fact, 7 and 8 feet of sea level rise this century is within the realm of plausibility should portions of the Antarctic ice sheet experience rapid collapse. We also have the problem of king tides, which today are rare, but are projected to rapidly increase to dozens of times per year within only the next 2 or 3 decades. King tides lead to saltwater coming out of our storm drains. They lead to the temporary raising of the water table so that it creates wetlands when it crosses the land surface. And of course, it leads to coastal erosion and high waves running up over beaches. And should we have a rain event at the same time that we have the highest tide of the day, we tend to get urban flooding because there's no drainage capacity. So what should we do about this problem? Focusing on Kaka'ako, I think that's a living laboratory, and it needs a plan with a foundation of governing design principles. I believe we should commit to the city's vision of denser, walkable, mixed-use communities close to transit, strategically relocate improvements above or out of flood zones, avoid the worst inundation areas until infrastructure studies and adaptation planning are complete or well underway, reward development shifts outside of the sea level exposure area, within the sea level rise exposure area, emphasize natural solutions, biomimicry, water management, enhanced access to recreation and flood resilient designs. The city complete streets approach should always be kept as a foundational principle for all modes of movement. Get away from the car dominated communities that we have. Make livable, walkable, rideable, open air communities that are heavily shaded. A mix of towers and low-rise living units, above ground floor commercial space, a mix of housing in the same community from affordable to luxury, localized education, childcare, and senior care, plaza-style gathering spaces such as SALT that include resilience, sustainability, and sea level rise, and heat adaptive characteristics. Flyover transportation corridors should be considered in certain areas because simply raising roads using fill creates a system of dikes, and the rise of the water table will lead to trapped bodies of water which won't be able to circulate and will likely be polluted So flyover transportation or raised access ways is going to be important. A design that's overall informed by cultural motifs that promote aloha, community cohesion, and equity, and a holistic water management approach, making use of artificial wetlands, temporary retention of water, designed for a one water approach where precipitation, polluted groundwater, tides, waves, storm surge, runoff, wastewater, and recycled water are all considered part of the same process and the same issue to be dealt with, to be managed. Promote innovative architecture, plumbing, energy, food transportation, and commercial design initiatives, and approach all this with private-public partnerships. Here's one example called Tanner Springs Park in Portland. They have excavated to the water table, created a wetland, and they've used the dredge to raise the surrounding shoreline and built a mix of high and low rise housing with ground level commercial spaces. It's a gathering place, it's cool, and it attracts local wildlife. Another example is in Norfolk, Virginia, where they have taken strong steps to adapting to sea level rise. In 2013, Norfolk released a new comprehensive master plan, Norfolk 2030. It detailed the city's vision with guidance from all sectors. Now, Norfolk is 97% developed, and the plan had a 20-year time frame. The plan's mission was preserving and maintaining the main elements of the city. It was a vision focused on preserving the city as it is today and did not provide the guidance needed to meet the challenges of tomorrow. And within 3 years of that plan coming out, they released an entirely new plan, Vision 2100, which focused on sea level rise, aging infrastructure, population growth, and uncertain regional and global economy. This is a map of Norfolk. Each of these color-coded areas implies certain types of planning. The red implies enhanced economic engines. It's home to key economic assets that are essential to the city's future. They propose to expand the flood protection system, build a comprehensive transportation network, transform less intense uses into denser mixed use patterns, diversify housing options available to residents, and strengthen and increase economic diversity. In brown is...
Sorry, Chip, this is Veronica. If I can ask you to please wrap up. I know you're towards the end of the presentation.
Yep, I'm almost there.
Thank you.
Brown is adapting to rising waters and using established neighborhoods that experience more frequent flooding. In green is designing new urban centers with a low risk of coastal flooding. And these have great potential for high density, mixed use, income development. And purple is establishing neighborhoods of the future. So are there economic opportunities in a new model for the visitor industry in Hawaii? The historic visitor model was based on growth, and it discouraged a diverse economy, and large aspects were not locally owned. In a non-expanding resource base, growth leads to crash. This is augmented by a lack of economic diversity and lack of local ownership. A new visitor model would have more locally focused, diversified characteristics, such as an annual visitor cap, a revenue model that leverages upper-level repeat visitors, subsidies promoting local ownership, tourism revenues focused on workforce development in diverse fields, decentralizing the visitor infrastructure, promoting low-profile, low-impact visitor distribution into communities. They are there already, but they're out of control. And a revenue model that regenerates those and neighboring communities. And between these, deconstruct portions of Waikiki to adapt to sea level rise and create more open space. So lastly, what lessons have we learned from COVID-19? It takes more than individual action to solve a global crisis. We are sheltering in place, and it has required personal action, but it's not been a personal choice. We're following shelter-in-place guidelines dictated by federal, state, and local agencies, And climate change, like a pandemic, can only be solved by systemic change that requires leaders making bold decisions informed by the best science. Have our leaders learn how to do this? It's not an either-or situation. In fact, individual action and systemic change are both required to move the needle on climate change. And I'll end with that. Thank you very much for your time.